Hey everyone, and welcome to This Explainer. I am absolutely thrilled to be your guide for today's topic. But before we get into the heavy science, I want you to start by just using your imagination for a second. Picture this, you're floating completely alone in deep space. Way off in the distance, you notice this perfectly dark sphere. There's no light, no reflection, literally nothing. So you decide to whip out the absolute brightest flashlight in the entire universe and shine it directly at this sphere. But the light never bounces back. It doesn't illuminate a single thing. It simply vanishes right into the void.
So what kind of object can actually trap light itself? It's a pretty profound mystery, right? Well, that is exactly the mind-bending phenomenon we're going to unravel today. We are exploring one of the strangest, most extreme entities in the entire cosmos, black holes. By the time we wrap up, you'll know exactly what these invisible giants are, how they shape the universe, and why they just might hold the key to the ultimate laws of physics.
Okay, let's dive into this. Here's our roadmap for today's cosmic road trip. First, defining a black hole. Second, the birth of monsters. Third, the point of no return. Fourth, journey to the singularity. And finally, how invisible giants die.
Right, let's kick things off with Section 1, defining a black hole.
Okay, first things first, we need to completely bust a really common myth right off the bat. A black hole is not some giant cosmic vacuum cleaner just roaming around sucking up everything in its path. That is pure science fiction. The reality? Well, a black hole isn't even an object in the way we normally think of one. It's a place. It is a region where space and time have been so unbelievably warped by mass that extreme gravity traps absolutely everything, even light itself.
To really help your brain process this, just think about a distance of 20 kilometers. Earth has gravity, right? The sun has vastly stronger gravity because it's just so much more massive. Now, I want you to imagine taking the immense, boiling mass of our entire sun and violently crushing it down into a sphere only about 20 kilometers wide. Not 20 million kilometers, just 20. Its gravity would become so intense and space would warp so deeply that light couldn't escape. That is exactly what creates a black hole.
Moving right along to Section 2, the birth of monsters.
So how do these things actually form? Well, there's this constant, violent tug of war keeping a massive star alive. Throughout their lifespans, enormous stars, and we're talking stars vastly bigger than our own sun, produce energy by fusing hydrogen into helium. This fusion creates a massive outward push of energy. But at the exact same time, gravity is relentlessly pulling all that mass inward. It is a super delicate balance. As long as fusion pushes out and gravity pulls in, the star survives in this epic cosmic standoff.
But eventually, that delicate balance suffers a total catastrophic failure. Step 1. The star's fuel completely runs out, and that outward pushing fusion just stops dead. Step 2. With no outward pressure left, gravity suddenly and decisively wins the tug of war, causing the entire star to violently collapse inward under its own crushing weight. Step 3. This collapse happens so incredibly fast that the core becomes intensely hot and dense, crushing matter completely beyond human imagination. And finally, Step 4. If the star is massive enough, literally nothing in the universe can stop that collapse. Boom! A black hole is born.
All right, things are getting intense. Section 3, the point of no return. We are talking about the event horizon. This is the literal edge of the black hole, the absolute boundary, where gravity becomes so unimaginably strong that nothing, not a spaceship, not an entire planet, not even a beam of light can ever escape back out. To kind of ground this crazy concept, think about swimming near a really powerful waterfall. Far away, the water is calm, you can easily swim back to shore. But as you get closer, the current gets stronger and stronger. Eventually, you hit a definitive point where no matter how hard you swim, you are going over that edge. The event horizon is exactly like that waterfall.
Now, what's truly wild about the event horizon is how it completely shatters our normal perception of reality, all thanks to Albert Einstein's incredible predictions about relativity. Listen to this. If you fell in, an outside observer watching from a safe distance would literally see time slow down for you. To them, you'd appear to just freeze right at the edge, basically suspended forever. But from your perspective, you wouldn't feel frozen at all. You'd just continue falling perfectly normally right into the darkness. Both perspectives are scientifically correct, because time itself literally changes depending on the strength of gravity.
Let's keep falling. Section 4, journey to the singularity.
Okay, so if you happen to fall into a smaller black hole, you're going to encounter a phenomenon with this wonderfully bizarre, highly technical scientific name: spaghettification. Yes, that is a real term. Because you're falling feet first. The gravity tugging at your feet is vastly, vastly stronger than the gravity pulling at your head. As a rather deadly consequence, your body gets stretched longer and longer and longer until you are quite literally pulled into a long, single strand of atoms before you even reach the center.
But what if you somehow miraculously survived all that stretching and reached the very, very center? Well, you'd arrive at the singularity. This is an infinitely small point where density and gravity just become infinite. Matter is completely crushed out of existence as we know it. And honestly, here is the most staggering part of all. At the singularity, the equations of physics completely break down. The rules that govern absolutely everything in our universe simply stop working.
Now, what's really interesting here is the ultimate cosmic conflict. Humanity's two absolute greatest scientific frameworks totally disagree on what happens at this exact point. Einstein's general relativity predicts that these crushing, infinite singularities absolutely do exist, but quantum physics vehemently argues that infinities shouldn't exist in nature at all. They completely clash. This is one of the biggest unsolved problems in modern science, which basically means we still don't actually know what is truly inside a black hole.
Pulling back out to safety now, Section 5. How invisible giants die. You know, for decades, scientists just assumed black holes lived forever. They were these immortal traps. But an astonishing discovery in 1974 completely changed the game. It turns out black holes aren't completely black after all. The brilliant physicist Stephen Hawking realized that they actually slowly emit tiny, tiny amounts of energy. We call this Hawking radiation today. So, as they emit this radiation, they slowly lose mass, they shrink, and eventually, over immense stretches of time, they will completely evaporate.
But hey, before you start panicking about a black hole evaporating somewhere in our galactic neighborhood, try to wrap your head around this absolutely staggering number. 10 to the 67th power years. That is a 10 followed by 67 zeros. That is the absurd length of time it takes for a sun-sized black hole to die. To put that into perspective, that time frame is vastly, vastly longer than the current age of our entire universe. So I can promise you right now, none of these incredible objects are disappearing anytime soon.
So, the crucial point is, if these things emit almost zero light and live practically forever, how do scientists actually find them? Well, it's like a giant puzzle. We look for their effects on the universe around them. We observe massive stars mysteriously orbiting completely invisible objects. We detect these incredibly powerful X-rays from gas violently falling inward. We even observe literal ripples in space itself, gravitational waves, when two of them collide. And culminating in a truly historic moment, scientists captured humanity's very first image back in 2019. Not of the black hole itself, of course, but of the superheated glowing gas illuminating its event horizon, perfectly confirming decades of scientific prediction.
And really, that brings us to the most important takeaway of this entire explainer. Black holes aren't simply giant cosmic monsters waiting in the dark to eat things. They are the ultimate natural laboratories where gravity, space, time, and quantum physics all violently collide. Every single new discovery we make about them pushes the very boundaries of human knowledge. Which leaves us with this profound, lingering question to ponder. By studying these absolutely dark frontiers, will we finally answer the biggest question in all of science and understand how the universe truly works? The darkest places in space just might be our brightest sources of discovery. Keep learning, keep questioning, and I'll catch you in the next explainer.